let's apply some of these naming rules for these hydrocarbons. We're going to start with our fully saturated hydrocarbons, which means that they are full of as many hydrogens as they can have on that chain. There are several different ways we can show organic molecules. You can just write the formula. So this is maybe done in a chemical equation. It's not really done when we're actually talking about the molecule doing anything. You can also write it in a condensed version. Or a more expanded version. Showing every hydrogen. But it does get very tiring drawing all these H's. So more often we would just drop those and just, you know it's a hydrocarbon. You know every atom's going to have 4 bonds because it's carbon. So if I don't draw the other bonds, you know there's a hydrogen there. Sometimes we'll also want to show the general shape of a saturated hydrocarbon chain, like this, or sometimes even just like this, which is called a line drawing, or a line formula. We know we're talking about hydrocarbons, so we know that every point here is a carbon. This is the shortest hand way of drawing it. This is the longest hand. You need to be able to recognize all of them, but I don't care which ones you do while you're trying to do your naming. I typically will do something like this one or that one, because I like to be able to see the carbons. Now if we count them, there's no substituted groups, so it doesn't really matter which side we start counting from. There are 4. If we look at our prefixes, the prefix for 4 is bute, and they're alkanes because it's saturated, there's no double bonds. So we would say butane. And that's the simplest kind of naming. It could get, if we look at a more complicated example. So here's our condensed formula. And as you get better at these, if you want to do your naming just looking at this, you can. But you can also always draw it out. I want to point out one thing. This only has 1 hydrogen, and it's bonding here and here. That means there's a substituted group because it has to have 4 bonds. And so we show the substituted group in parentheses right here. This same thing here. This carbon has this substituted group off of it. So when we draw it, I'm not going to draw any of the hydrogens. I'm just going to remember there's 3 here, 2 here, only 1 here. So there has to be something else. It doesn't matter if you put it on top or bottom. We don't really have a way to know which it is. There we go. So this end is 4 away from a substituted group. This is 3. So we're going to pick this one to number from. That's 8 carbons. That means it's going to be an octane. This is a methyl group. And this is an ethyl group because this has 1 carbon and this has 2. And whenever they're substituted groups, we end them with YL. Alphabetically, ethyl comes first, so we would write it first. 5 ethyl, 3 methyl octane. Let's look at another example. For this example, I wanted to give it to you already drawn out because I want you to start getting familiar with recognizing them in whatever form they come in. This end is closer to a substituted group, so it's going to be carbon 1, and we'll number from there. We have 9, so we know this is going to be nonane. This here is an ethyl group because it's got 2 carbons. And these are both methyls. And because there's 2, we would say dimethyl. So alphabetically, ethyl comes first. 3 ethyl. 5, 5, tell where both of them are, no matter what, if they're on the same or not. Dimethyl. Nonane. That tells you 9. All of this up here is your work. It's how you get to the name. I'm not checking this work, so you can do it however you want, wherever you want. All I'm checking is your name. Now, if you are making mistakes, I can't help you unless you do show work, but you aren't required to for naming. Let's look at this condensed formula. CH, so we know that there's one substituted group and it's right here. But then there's something else in parentheses. This is not telling you about substituted group because you can tell, because there's a hydrogen here, that there's only one. This is just telling you 4 more of these. So I could have written CH2, 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 or I could just shorten it like this. If we write this out, 1, 2, 3, 4. 1, 2, 3. And because this substituted group is closer to the end, we'll count from here. 2, 4, 5, 6, 7, 8, 9, 10. You might notice that 8, 9, 10, this chain is just as long, or even this chain. It doesn't matter because when you make the formula, it would be identical. This is a methyl, and this is a propyl, because it's 3. 2 methyl, 7 propyl, and it's 10, so it's decane. Let's try one more example. So let's look at this. It looks very complicated, but because this obviously has only no substitute groups, this is just shortening it out. So 1, 2, 3. This carbon has no hydrogens at all, which means it has to have 2 substituted groups that are denoted right there. Same with this carbon. And it has 2 substituted groups, but they're not the same. So they're shown in separate parentheses, one after the other. There's our 2, there's our 1. And we have this. Now we usually have this end with CH3, but if you draw this out, you'll see it's the same thing, right? We could have written it CH3 and then put another CH3 on the end. It would be the same formula. And we're going to count from this end. 1, 2, 3, 4, 5, 6, 7, 8. So that is octane. We have 1, 2, 3, 4, 5 methyls. So that is going to be pentamethyl and 1 ethyl. So our ethyl, 3 ethyl, and you have to tell where every single methyl group is. 2, 2, 3, 4, 4, pentamethyl, octane. So the names can get really long and really complex, but the rules are the same. So take it step by step. Draw your chain, number your chain, identify your groups, and then in your name, put the substituted groups alphabetically and always tell what carbon they're attached to.